Hello, today I am making this video to explain the payment processing service, and in specifically I'm gonna explain how the factory design pattern is implemented in this service payment processing service, and what is the need of factory design pattern to use in this project. First of all, what is our basic system is, so this is our payment integration system. Here we're gonna create the three microservices. So this one is validation microservice, this is payment processing service, and this one is our Stripe provider system. So we have done with Stripe provider system, we have created this. Now we are focusing on the payment processing service. This is the merchant system, and this is our Stripe PSP. So how is the flow? See, the merchant system sends to the validation service microservice. It sends the request of the payment to this validation service. The validation service validates all the necessary parameters for that payment. For example, the daily limit of transaction, the amount limit, and this gonna check in this validation microservice. Then this validation microservice calls one of the API of the payment processing service. So validation service calls sends the request to the payment processing service to further process that payment. In this payment processing service, we are creating the two APIs for creating and initiating the payment or transaction. So this is for create transaction, and this one is for initiate transactions. So we are creating two APIs for that, the create transaction and for the initiate transaction. So what is the work of these two APIs? The validation system sends requests to the first API called create transaction API, where the create transaction API make the changes to the database. So here is the database of payment processing service. The create transaction, when the create transaction API is get called, the payment status is updated to created state in the database. Then the create transaction sends back the unique ID. The ID is generated in the create transaction API, and the database updation is gonna is going to be there, that payment status is updated as created and the necessary information gets stored inside the database. That ID is get returned to the validation system. The validation system may have other logic to process that ID. That, for example, they can also be stored inside their database. Okay, then when the validation service after receiving the ID, it checks for the does its work and sends the API call to the initiate transaction to initiate the transaction, that all is okay. Now validation service request to the payment processing service that initiate this transaction. After receiving the call to initiate transaction, the payment processing service updates the payment status as initiated in the database. It changes the payment status to initiated state. Then it calls to the Stripe provider system for creating a session. Our create session API is get called, and in turn the Stripe provider system contacts or make a call to the create session API of the Stripe PSP. In return, the Stripe PSP gives the ID and the URL. ID URL information to the Stripe provider service system, and Stripe provider system gives back it to the payment processing service ID and the URL. Let's say the URL. So after receiving the URL, the payment processing service again update the status of the payment status to the pending state, and gives back the URL to the validation system. Validation system in turn gives back to the merchant system this URL, and then this merchant system gets redirected to that URL. That URL is nothing but the URL of Stripe hosted payment page. So after completing the payment, it gives to the Stripe PSP the status of the payment. Then Stripe PSP gives back to the Stripe provider system the status via the webhook. Then the Stripe provider system gives that notification to the payment processing service. We have payment processing service has the another service called Stripe notification controller. So after receiving that notification, either success or failed, it again updates inside the database that either success or failed. So in this way, the payment processing service has a centralized way to handle this status: created, initiated, pending, success, failed. What happened in this case, that See, this is our payment service implementation class. Okay, and see, we have to create this database, and to handle all the database logic we have to create a DAO layer, or we can say the repository layer. So we are creating the DAO layer with transaction DAO, which is annotated with repository. So this class handles all the database logic, means it directly updates the status, payment status of the in the database. So this is the payment service implementation class, and now we have to create repository layer, name is transaction DAO. We are creating this where all the database logic resides inside this transaction DAO class, okay, which directly access or updates this database. So payment service IMPL, what we have to do after receiving the create transaction request, the payment service implementation should call this repository layer, right? And to make it enable, we have to inject the transaction DAO inside this payment service implementation class. See, in payment service implementation we have create transaction and initiate transaction services. So when the create transaction request has come, to fulfill this request, the payment service implementation should call the repository layer to update the payment status to created and save the all necessary information about that transaction. Then initiate transactions work is to update the payment status to initiated state. And to make it possible, it also has to call this DAO layer to update the payment status to the initiated state. Okay, then we have other REST API calls to if success, we get the success, we have to update, means after we getting the successful URL of the Stripe hosted payment page, we have to, that means it has to update the payment status to the pending state. Yes, and if it receives the fail, then it has to update the payment status to failed. And for updating the status, these also have to call the DAO layer directly. Yes, again again as I said, we are gonna create the notification uh, the Stripe notification controller, which handles the success or failure notifications from the Stripe provider service. Then see, if the notification, it receives the notification as success, they have to update the status of the payment as a success. Or if it receives fail, then it has to update the payment status as failed. So to make it to update the payment status success or failed, it has to access this layer again. So we have to inject here also the transaction DAO, so that it can raise a request to update the payment status. So this is about the Stripe notifications controller. That means now the DAO layer receives payment status updation requests from payment service implementation, from REST API calls, from Stripe notification control, and we gonna design the recon service inside our project for reconciliation, for checking the pending transactions. So it receives pending transactions and check its status and resolve it. It either mark it as success or failed. Yes, mark it as success or failed means it has to again update the status of the pending transaction to either success or failed. So this is our system where the payment status updation requests are for payment service implementation, Stripe notification control, from recon service also. Now the it becomes very heavier at this transaction DAO layer to handle all these requests at a time. So there must be a way to handle this situation and decrease the complexity. So for this, the factory design pattern is there, which is the design pattern, yes, to handle this type of situation. There is a factory design pattern which says that there must be a factory class where, or factory class which returns object of the class based on the inputted request, based on the input request. That means depending on the input request sent to this factory class, it pick up the object of the required class and returns it to the subclass. That means it is a factory of the objects. It's its aim is just to provide the required object. Factory design pattern says that the factory must be a method which return type is of parent class, which return type is of parent class. Okay, let me explain this. See here, what we are gonna do here, that we keep aside this DAO layer away. That means as we have done in Stripe provider system, that we created a centralized system HTTP service engine to accept all the incoming requests, and so that the means we centralize in Stripe provider system the incoming request, all incoming request goes inside that service engine, and it handles the further process. So in this same, we are gonna design here the factory design pattern for handling these requests as payment status updation request. So let's see how. See, rather than sending these request directly to the DAO layer, it increases the complexity. What gonna make, we are creating one centralized system called payment status service. So we are creating this payment status service, and in this payment status service, we are gonna creating this as an interface, and we are going to create its payment status service implementation class, which implements the payment status service, and it has one method like process payment, which receives the status from the payment service implementation or any calling requesting component. Then what now, the payment service implementation, REST API calls, type notification controller, these are all called to this payment service called to this payment status service to update the status of the payment. So these all request to the payment service payment status service rather than to the DAO layer directly. So here what we have to do is here we are getting the status from the requesting component. So we are checking the status, that if status is equal to created status, if status is equal to created, then here all the business logic to update the status, to update the payment status inside this transaction DAO, means it calls this transaction DAO. Then we have to check else if status is equal to initiated. If status is initiated, then here is the business logic for initiated. Else if status is equal to pending, then to handle all the business logic here. Here also we have to inject the transaction DAO so that it can call to the transaction DAO layer, repository layer. So now what happens here, we are handling all the business logic here. See, created, the business logic for created is different, business logic for initiated is different, and business logic for pending status is different. That means all the statuses are different in nature, they are not dependent on each other. So we can do one thing here, writing down this business logic here, it increases the length of this if else ladder. So instead of writing here business logic, we are just write here the functions, methods. For example, if success is created, then this is created process created status, process created. Okay, here if status is initiated, then process initiated method, and if status is pending, then it calls the process pending method. And here we are writing down these methods, process created. So all the business logic now we are writing here. Process created, process initiated, and process pending. So what happens, this length of the if else if ladder gets decreased, but still the code of this payment status service implementation class is very lengthy, right? Now as I say, the business logic for created payment status, for initiated payment status, for pending payment status is different in nature. So we can create all these classes, separate classes. See, for example, we create here created status processor to handle all the business logic for this created status. Here we can mention this process created method, yes, which processes the created status. Then, and this class annotated with service because it provides the service. Then next different class we are creating, that initiated status processor, in which we are writing all the process initiated, means all the required business logic for processing the initiated status. Then we are creating another class for pending status processor, and here we are creating a method process pending. So all the business logic is inside this method. Here also and here also. Now what happens? Now what happens? See, we are creating this much code inside the another classes. We are creating for classes, the separate classes for here. So now directly we don't need to write this code inside this payment status service implementation. Automatically the length of this class decreased. Okay, now instead of calling directly these methods, we have to create the object for these classes. We have to inject these classes here, and we have to create the objects of these classes here. So this also is very hectic. So what is the solution over that? That created these three service classes have some same nature, that it follows some same nature, that is it is processing some status. So rather than making it as a separate classes, we are making it child classes for the an interface called transaction status processor. This is an interface, okay, which has a method called something is return type and process status. And we are sending some request to that. So this is an interface, and these are the child classes of this interface. That means these child classes implements this interface, so that we don't have to mention these method names different. Instead of that, we have to mention the process status. So it will be very easy to the developer when debugging this or testing this code. Yes, these classes implements the transaction status processor interface and override its method process status, process status, process status. Now instead of creating all these classes objects, we have to create here the object of transaction status processor. Yes. And here we have to call only same method. Okay, now this can be directly okay. Now what says the factory design pattern is that there should be a factory class. So we are creating a factory class so that this coding is also get decreased inside this payment status service implementation class. So we are creating a factory class called payment status factory. What must be the role of this payment status factory is that this factory class should return the object of the class, object of this created, this initiated, this pending processor service class, depending on the status to be passed. That means here inside the process status factory we have to create one method called get process get status processor. Yes, and here is the input parameter is status. And what factory design pattern says that the return type for this method must be the parent class. So the parent class is transaction status processor. Yes, now here go all the all this logic. If status is equal to created, then return new what created status processor, object of created status processor. Else if status is equal to initiated, then return new initiated status processor. Then else if status is equal to pending, then return new pending status processor. So the the aim of this factory class is just to return the object of one of these classes. depending on the input status. So the need of this code is also not needed here. Now what is the aim of this is just to call the payment status factory. Just creating this object, injecting inside by using constructor injector, and we have to call the method of this factory class, factory dot get status processor, and we have to send the status to that. And what it returns, the return type is transaction status processor object. So we are creating one object of that and saving inside this. See, this is not needed now, so I am removing this. And what is our new code inside this, that we have to inject the payment status factory object inside this, and we have to call the this factory's get status processor. It the status processor gives the status processor, this factory gives the object depending on the status we have passed here. If the status is created, that means status id is 1, that means it gives the object of created status processor. If the requesting status is initiated, then it returns the initiated status processor, like that. So after receiving the object of the required class, processor class, it should call to the transaction status processors. So ref dot, the method is process status. Done. That means after receiving the object of the required class, it calls with that object the process status, the overridden method of the transaction status processor. And now this handles this communicate with this DAO layer. That means the payment service implementation, or whatever the components which requires to update the status, payment status, they can send a request to this payment status service implementation class. This in turn contacts with the payment status factory the payment status factory gives it return the required object of the class, and then it calls to the overridden method of the process state transaction status processor, and then it updates contacts to the it sends request to this transaction DAO. So this removes all the complexity which arrives when we are directly sending request to this DAO layer. So this is the power of this is the factory design pattern. It is a design pattern that whatever if the situation is like this, that we need to choose between the objects, that if the request is this, then we need the object of this class. If request is that, then we need the object of another class. If this type of situation is there, then we can use this factory design pattern. We can create a factory class where it returns all the objects required class object of the class depending on the input request. So this removes the complexity of the complexity to while coming directly contacting with this transaction DAO. So we are implementing this concept inside our project for handling the payment statuses. So this is the need of the factory design pattern should be there to remove the complexity, and it separates all the logics. It separates all the logic so that the complexity is automatically decreased here. Okay, now let's implement this inside the code. So for the implementation of this into the code, I'll record the next video. Okay, thank you.